Okay, we started with ratios and proportions, which will allow us to work with similar polygons, okay? That's what today is, similar polygons. We're going to be dealing with what similar polygons are, what a similarity statement is, okay? What a scale factor is, and you'll be surprised you already know this, okay? And ratios of perimeters. Now, here's your resources for this particular section. In the Chapter 7 notes I gave you, pages 8 to 10 talk about similar polygons, okay? And then the notes, the PowerPoint presentation, Chapter 7, Section 2. Okay, here we go. Similar polygons, in the second section here. Okay? Two polygons that, for lack of a better term, look alike, okay, with the same shape, okay, so they have to have the same number of sides. Let's accept that, okay? They're not going to be the same size. That's the important part. They're called similar. The symbol for similar is an S lying on its side. So this would be triangle ABC is similar to triangle XYZ. Just like congruent triangles, you must match vertices. Now, if two polygons are similar, it is because they have both of these stipulations. First, corresponding angles have to be equal. Okay? And the corresponding sides have to be in proportion. Okay? Now, here's just such an example. I have two quadrilaterals. The sides are there. The marks are there to show us which angles are equal. Okay? And remember, we're always going to have those little marks or degree measures. Okay? Usually the little marks. We don't use too much in the way of angles here. So this would be what we set up. Quadrilateral ABCD is similar to quadrilateral EFGH. That is the similarity statement. You'll be asked to do that on part of your assignment today. Okay? Now, corresponding angles. Yes, the ones that correspond are equal to each other. So, check. Corresponding angles are equal. Now, if you weren't sure what corresponding sides in proportion means, it's right here. 5 over 2.5, okay? Be consistent. If I started with the left on the top of the fraction, that's how I do it all the way across. That's the most common mistake people make, okay? The math on this is pretty easy. If you don't set it up right, that's where your problems come in, okay? Then we go 6 over 3, 7, 3.5, 4 over 2. Since each of these fractions, ratios, simplify to the same thing, that means the sides are in proportion. Okay? So if all of those ratios simplify to the same thing, okay, on this extended proportion, I talked about that in the last lecture, okay? Now, this is important because this 2 over 1 is what's known as our scale factor. Okay? The scale factor is how you find other sides. Watch. Okay? If we go to a map, okay, there we go. This right down here is called the legend. This is not the state of California. Okay? It's smaller. Trust me, it's smaller. Okay? But this legend, the scale factor, tells us how to deal with that. Okay, so for every inch on the map, we're looking at 25 miles of actual driving. That's a scale factor. It helps us figure out the proportion. And finally, when we talk about ratios of perimeters, what I did, okay, remember the perimeter is the length of the sides added together. So the perimeter of this is 22. The perimeter of this is 11, simplifying to 2 to 1. Important to remember this, folks. It's going to make your life a lot easier. The ratio of perimeters is the same as the scale factor. Okay? Let's do some problems. Okay? here's our first example. Okay, let me straighten up the camera. There we go. Oh, that's just a lovely. Let me see if I can change the lights here. Oh, that's even worse. Golly. I'm trying, folks. Okay, we'll just do it this way. It says, examples. Okay, I have one quadrilateral here and another. I am told, as part of the problem, that they are similar. So, we have to find the scale factor. First thing we want to do with the scale factor is to find two corresponding sides, one from each, that both have numbers. Okay? So in this case, I've got 10 and Z, 20 and 30. That's it. Okay? So I set them up as a ratio and simplify. So my scale factor is 2 to 3. Now we want to find the values of each of the missing sides. To do that, we use the scale factor. So let's start with that, and it doesn't matter what order we go in. Okay, so 8 over Y. Cross multiply and solve. 2y equals 24, y equals 12. Okay? I do the same thing for each of the sides. Okay, the next one is x over 21. Okay, 3x equals 42, x equals 14. And finally, 10 over z. Okay, 2z equals 30, z equals 15. Okay, so now it wants the perimeters of each quadrilateral. Well, we can do that now because we have the actual lengths. Okay, so we're just going to be able to add them together and figure out what it is, okay? So 30, 38, 52 over here. $15, 45, 57. I think that's right. 30, 60, 78. Okay? And the ratio of perimeters, we already know, is the same as the scale factor. So there we have it. Okay? It'll be easier to see when I take the pictures for you. Okay? Next, determine whether each pair of figures is similar. If so, write the similarity statement and the scale factor. If they're not similar, write the reason. Okay, so here we go. We've got a pair of congruent angles, a pair of congruent angles, and since it's a triangle, we know that these two have to be equal to each other. So now we look for the sides that correspond. Okay, between 1 and 2, 1 and 2. There's a 16 and a 24. Okay, A to C matches there. Okay, and 14 and 21. What you do is check to see, are those all the same fraction? Okay, 8's the common, so 2, 3. 6 goes in 2, in 3. 7, 2, and 3. Yes, they are similar. And 2/3 is the scale factor. Okay? Now, we look at this. 1s, 2s, 3s, four-sided figures all add up to 360, means that and that have to be equal to each other. Okay? I'll go ahead and use the green on this one. Okay. Oh, I'm sorry, the similarity statement. Okay, when we are doing the similarity statement, we have to match them properly. So the A and the U go together. And I just do it this way. I go to the 2's, and then in this case the unmarked, so C and T. Okay? Now down here, we're going to do it the same way. We have to match. Okay? So I'm just going to go 1 to 2, 1 to 2. So 20 over 12. Okay? And then the 2 to 3, 15 over 9. Okay? And then the 3 to none. Don't freak out if there's decimals. That's why you all have calculators. Okay? And then no mark to 1 mark. Okay? Okay. When you divide each of these, okay, and you'll find your factor here is like 4.8, they all simplify. So there's the scale factor. The sides are in proportion. Okay? So yes, they are similar. And now we match. Okay? So I'm just going to do this. JKLM is similar to QRSP. And there you have your determining factors. Are they similar? Yeah, they are. Because the sides are in proportion, because corresponding angles are equal. If one or the other was not true, then no, they are not similar to each other. That's all you have to figure out. Corresponding angles equal? Check. Sides in proportion? Check. Okay, that's it. Okay, couple more. Now we're going to figure out some things here. On these two, on numbers 3 and 4 here, okay, each pair of polygons is similar. So we've got that down. Okay, we want to find the value of x. So what we have to do here is line them up properly. Okay? Between A and B, between the 1 and the 2, between the 1 and the 2. That's my first. Okay? Okay? And then my second one. Okay? Between the 2 and the 3, between the 2 and the 3. So 10. Those go together. So these are equal. Okay. Now, we're going to cross multiply to solve. That is taking you back to algebra. Okay. If you are relying on your calculator, it's going to be 1.5, perfectly acceptable. Okay. So now we come over here. Okay. Once again, we are told they are similar. So, in this case, match them up. Okay, I've got a 1, a 2, and a 40 degrees. A 1, a 2, and a 40 degrees. So, between the 40 and the 1, here and here, is my first one. Okay. Obviously, the 12 and the x plus 1 go together. And I'm going to do the same thing. I'm going to cross multiply to solve. Okay, combine like terms. And we find that x is 7. Okay, that's how you find them when they're in that situation. Okay, our last question, kind of interesting here. Our directions tell us A, B, C, D, E is similar to P, Q, R, S, T. So these pentagons are similar. Okay, we want to find the scale factor. Okay, we know how to do that. And we want to find the perimeter. Now, the first thing I'm going to do here is this. Look at this. Okay, the 2's, 1's, okay? So this is a 3, this is a 3. Okay, so they go together. The 2's go together. So the 15 and 21. Now this tells me that those 3 sides are equal to each other. That tells me they're going to be equal to each other over there as well. Okay? So when we find that, we're going to be able to deal with it. We don't have a number there, we can't do anything. Here are our numbers. That is your scale factor. Okay? So now that I know 5 over 7, I can find the remaining sides. Okay? Okay, we've got that one. Okay, this one, obviously I only have to do once. Okay. Now we have all of the sides. Right? Write it that way, I'm saving space there. Okay? So all we're going to do right now is just add them up. Okay, that's one way to do it. Just find the actual sides of them. Our other way to do that, okay, we were able to figure those out pretty quick. So we can set up a proportion, okay, using the scale factor. Perimeter of this over perimeter of this. Cross multiply and solve, you're going to get the same number. Both ways are correct. Both ways will get you your answer. Use the one based upon the information you're given. Sometimes you're not going to be able to find the entire length of each side. Sometimes you have to do the proportion with the scale factor to find it. Okay? Which you can do. You're bright people. I trust you. Okay? Okay. Very good. Talk to you soon.